The Rhind Papyrus, sometimes called the Rhind Mathematical Papyrus, is one of the best-known examples of ancient Egyptian mathematics. This extensive scroll was made around 1650 BC and contains mathematical tables and problems. It was purchased in Egypt in 1858 by a Scottish antique collector, Alexander Henry Rhind, after whom it was named. The Rhind Papyrus has been owned and displayed by the British Museum since 1865. Cyperus Papyrus, known by several common names, provides the base for the modern word paper. The ancient Egyptians made a type of paper also called papyrus from the stalks of this plant. They attached multiple sheets of this paper to form scrolls on which they wrote. This paper was made exclusively in Egypt and was later exported throughout the classical world. The Rhind Papyrus is a manuscript that's about 13 inches tall and over 16 feet in length. It was copied by a scribe named Ames around 1650 BC. Ames is the first contributor to mathematics whose name is known. He was also the first mathematician to use fractions, although he claimed to be only a scribe copying the work from an older document from around 2000 BC. In the opening paragraphs, Ames wrote that the document contains accurate reckoning for inquiring into things and the knowledge of all things, mysteries, all secrets. The Rhind Papyrus is divided into 3 parts or books. The first deals with arithmetic and algebra. Book 2 is on geometry, including volumes, areas, and pyramids. The third book contains 91 miscellaneous problems and solutions. Let's briefly consider Egyptian fractions, which appear extensively in Book 1. An Egyptian fraction is the sum of unit fractions with different denominators. Unit fractions have 1 in the numerator. 5/8 is an Egyptian fraction expressible as 1/2 plus 1/8. Similarly, 13/12 can be written as 1/2 plus 1/3 plus 1/4. Egyptian fractions are useful, for example, for dividing objects into equal shares. In the Rhind Papyrus, the objects are frequently loaves of bread. To divide 5 loaves by 8 people, give each person half a loaf plus 1/8 of a loaf, perhaps by cutting 4 loaves in halves and 1 loaf in eighths. In addition, the papyrus contains a table expressing fractions of the form 2/n with odd n from 3 to 101 as sums of unit fractions. Interestingly, these decompositions never require more than 4 terms, and this section of the manuscript spreads over 9 sheets of papyrus. I've displayed a few selected examples from this extensive table. That's all I have for now. Until next time, do some math and have some fun.